Last session of the day, let us make it great. Stormwater drainage is a very near and dear subject to me because basically I am a civil engineer and I have done many infrastructures. I would like to tell you about the global picture of stormwater drain and then again how the building stormwater drain should function. So first slide of the stormwater drain. What is the stormwater drain? As I mentioned in my earlier presentation also, it's a art. Stormwater drainage is not a very technical. Of course, it's a very technical process, but then it's a art because in earlier we discussed about water supply. So you know the start point, you know the end point. Here you need to decide a path where where the storm water will get discharged out of your property very quickly. Anywhere, either your property has roads, roofs, parkings, gardens, anything. Wherever the rainwater is falling, it should be quickly drained off out of the property. Otherwise, water logging will be there. It creates a havoc-like situation. It damages the property in long term and short term also. So we can bifurcate stormwater in two ways. Basically, one is building part, second is infrastructure part, which is around the building and outside the building. There are several codes and standards. Mostly NBC covers the stormwater drain design for the building part. Okay, so roof areas and the around areas within the plot boundary. However, if you want to design the stormwater drain for the infrastructure, the plots like 1000 acres, 5000 acres, like that, then there are CPHH EO manuals are there, which gives you the various factors, codes, formulas to design the stormwater network for infrastructure. If you are designing the stormwater network for cities, then CPHH EO manuals need to be used. There are various materials used for the draining of stormwater network. It starts from RCC pipe. There are various categories in the RCC pipe, which is NP1, NP2, NP3. NP3 is the most strong pipe, which takes the most load of the vehicular movement. NP2 is little inferior to NP3. NP1 pipe are not much used. It used to design, earlier days, quite long back they were used, but not now. So NP2 pipe and NP3 pipe are quite famous. If there are heavy loads like truck loads or fire tender loads, then with proper encasing, NP3 pipes can be used. Then there are HDPE pipes, high density polyethylene pipes. There are two HDPE pipes. One are used in the building drainage, okay, and they are from the international manufacturers. But those pipes are based on EN standard mostly. However, as per Indian standard, IS 14333 is the code for drainage pipes, which that drainage pipe can be used for soil and sewer, which has a good abrasion resistance, load bearing capacity that can be used in the infrastructure. Then DWC, double wall corrugated pipes are there, rigid PVC pipes are there for the external. But inside building, we can very well use UPVC 13592 IS code pipe for the rainwater. Now there are two type of pipes in the rainwater. One is type A, type B, based on IS 13592, which is drainage pipe. So type A and type B, I will tell you simply how to remember. Type B means better, A is inferior. So B pipe are mostly used in the soil wastage, and A category pipe are used for the ventilation where there is no water flow is there. Many of the places, type A pipe is also used for rainwater because it is assumed that there is no pressure or there is nothing and A pipe can be satisfied. However, that is the most incorrect thing, because whenever there is a rain, huge rain, we all observe for a continuous period of time, what happens? The pipe starts filling because discharge is limited. Okay, pipe starts filling, so the water builds huge pressure on the fittings also. So it is better to use B grade pipe, which is better in terms of taking pressure and other loads. So there are various materials. Then there are polypropylene pipes, which are better than UPVC pipe. But if we go for economic case studies for the buildings which are less than 20-25 story, you can very well go for UPVC IS 13592 B grade pipe. B is better. Now we will go through the topic storm drain, prohibited connection, subsoil drain. So these are the terminologies. I also mentioned in my earlier session that terminologies are very important. So drains, roof drains, strainers, leaders, conductors, connections, siphons, undergroundings, drains, materials, traps, required. So these are the infra connections. You can see a human-like height, like 6 feet pipes are there for the stormwater connections in the infrastructure. So terminology, I will not be explaining. You better learn it. There will be quiz context in which you need to answer for the terminologies also. So basically very simple, roof drain, which has a collector, and then there is a pipe which is horizontal through vertical, it is called as conductor, then clean out plug for cleaning purpose, then outlet to the external. Pipe plus scuppers, this will come in detail in next. So sewer pipes and stormwater drains. Again, there are two type of infrastructure network design. One is combined system where sewer and storms are designed combinedly. If the cities are small like villages and all, some sewer networks are allowed to take the peak rainfall load so that the property will not be flooded or the village will not be flooded. Sometimes it is very specific, the sewer will take sewer load. Over there you will see the manholes with proper double seal covers. However, where you can see the manhole covers with the openings, you can easily understand they are a combined system. So whenever the huge rain is there, the storm water will take the rain water, also the sewer will take partial load of it. So subsoil drains, perforated and slotted drain pipes. Some of the manufacturer provides you this type of pipe. So what happens when the structure is getting constructed? They excavate. You must have seen there is a foundations. So there is a water from the earth, and that water from the earth exerts a pressure on the that building or foundation, and because of that there is a possibility that structure get collapsed, it get uplifted. So that water is called as uplift pressure. Now to safeguard that subsurface drain concept has arrived quite recently. So what do they do? Around the property they run a perforated pipe, in which through these perforations the groundwater is allowed to get in the pipe, and then at some end, probably somewhere, there is a sump, and the sump is installed with the pumps which lifts the subsurface water so that the property can be safeguarded. You might say, then there can be the soil. So these pipes are wrapped with geotextile materials, which does not allow the soil to get in, but just water to get in. You can see the construction and the pipe materials. Earlier, these used, when I think I am talking about 15 years back, we used to get this custom pipe So someone from the plumbing contractor can make these type of holes, slotted holes. But nowadays these pipes are available ready-made. Then sump pumps, submersible pumps are there in that sump, which we discussed here. And the water gets lifted based on high level, low level indicators, which we discussed in the earlier session. Also, while designing the sump, I will add something here. While designing the sump, you should take care of few things. One is, what is the solid handling capacity? So usually pump can have 35 mm, 40 mm, 70 mm solid handling capacity. This is not the crusher pump of sewage. This is the stormwater lifting pump. Then the height of the sump should be such that the maximum there should be sufficient freeboard available above the pump. The pump should be submerged sufficiently and freeboard. Otherwise, your pump, it is known that the pump will suck the water from bottom. So just if you are designing the sump in such a way that the pump bottom is only submerged, then it is the incorrect design. Next is plinth protection. As we see here, what will happen? The plinth of the structure can get protected because of the draining of subsurface water. So plinth protection is there. Open surface spaces. This is there in the detail. Primary roof drains. There are two types of roof drains, primary and secondary. So what primary does and what secondary does. So there are two types of rainfall. One is a peak rainfall. So जो हम लोग देखते हैं कि बहुत तेज बारिश है, that is what is peak rainfall, and then there is average rainfall, which we can see, we can understand it. So primary roof drain is to carry out the general rainfall, whereas secondary roof drain is to carry the peak rainfall. So what generally we see, we only design primary. Whatever generally you are seeing at terraces, that there are rainwater inlets which are connected to pipe, they are primary. The areas where the rainfall is huge and continuous, like if we talk about Cherrapunji, where the rainfall is huge, there this type of primary and secondary are practiced. Mumbai also falls in mid, but still primaries are focused. This is the installation, that primaries are more deeper and secondaries are above. So that what will happen? This will get submerged quite quickly. If the rainfall is huge, peak rainfall is there, this will get submerged very quickly. And what will happen if it gets submerged? So it's a very, I like this example a lot. In our childhood, we used to play with a tube. There is a small tube and we fill it with water or petrol and we hold the thumbs above the tube. What will happen? Water will go or water will not go? Yes, water will not go. Why? Because there is no air for water to pass. So if there is no air, what will happen? Water will not pass. So in that case, the secondary system comes to the rescue. And because there is a air available, the water will pass. The secondary is also called as emergency. These type of drain systems are there. Sometimes CI, PVC, different type, different shapes, and then corner drains, because these are very famous. We don't want the rainwater outlet to come at the center of the slab. So usually they are connected where the shaft is there, and near to the shaft the pipe is directly connected, and this collector point is there which will get the water and it will discharge in the vertical pipe. The underdeck clamping, testing of stormwater drain. The tests are very important. In the water supply we didn't talk, maybe next lecture I will tell you, but testing is very important. So the complete system, although it is a gravity system, the pipe is completely filled and it is allowed for 15-minute duration. If there is no leakage, water is at the same level, then the test is successful. There are vapor tests are also available, air tests are also available, which has different durations for the tests. This part I will run quickly. This is nothing but there is always question comes that if this is the roof and there is a vertical wall, how to calculate the runoff? So 100% of this horizontal roof and 50% of vertical area. Okay, so if you are this particularly comes where you must have seen the large canopies at the entrance of such type of buildings. So how to design that canopy? Does anyone will allow you that the rain is falling on the canopy and it is coming out from all the places? No. How we will design the drain around it? So this is the criteria. Vertical part 50% and then this is 100%. Accordingly there is a different percentage. So this is 100%, then this is 35%. Different configurations. It is common that one cannot have, if the rain is from this direction, one will not have any rain. Only this part will have rain, second part. Table for ceiling suspended gravity horizontal rainwater pipe. So this is nothing but a table which tells you that slope is 1%, which is 1 in 100. What will be if the diameter of pipe is 100, then Qmax is 4.2 and velocity is 0.8 meter per second. So while designing the stormwater or sewer network infrastructure horizontally, you have to be very sure about the self-cleansing velocity. So pay attention, there are 3 velocities: self-cleansing velocity, then settling velocity. So what is the issue in settling velocity? If the slope is not appropriate, there will be deposits in your pipe which will reduce the cross-sectional dia of the pipe and your stormwater drain will not be efficient. And then there is a third one is scouring velocity. If you give the more slope, what will happen? The sediments which are traveling in the pipe will give more abrasion and the life of the pipe will be reduced. So self-cleansing velocity is the optimum velocity you should always maintain. Usually it is 0.8 meter per second. It differs for different pipes because the friction factor of the different pipe is different. RCC pipe will have more friction factor, HDPE pipe will is a more smooth surface, less friction factor. So slope would be less for HDPE pipe and more for RCC pipe. So these are some of the ready-made self-cleansing velocities are mentioned. You can always check it with your design. How to select the rainwater pipe with reference to the rainfall. This is you can see one table given in the NBC which will tell you how to design the rainwater pipe. This starts here and this ends here. Very little complex table. Try to understand. So if you have 100 mm per hour rainfall intensity, these are the rainfall intensity rows. So 100 mm rainfall intensity and the area is 84 square meter. I will select the 100 mm pipe. Very simple. Nowadays, how much we take in Mumbai for designing roof? This is for designing roof, not for infrastructure. 1. Good. It's a very huge rainfall intensity. Honestly, trust me. 150 mm per hour is not even happened on the 25th July 2005. It was 800 mm over 12 hours. It was never crosses 100 mm. Either the system is inefficiently designed, incorrectly designed, without proper slopes, pipe sizes, ventilation systems, That's why the system is not functional. And we tend to design it for, I remember 75 I started, now I am designing it for 150 mm just to safeguard, just because of client's inputs. Whatever is the condition, the property cannot be flooded. So anyways, so I said this starts here and this ends here. If rainfall intensity is 150 mm, pipe dia I have to select 100 mm because of the shaft space constraint. Then 56 square meter is the only area it can cater. If you have the roof of 560 square meter, how many pipes you will require? 100. फिर तो क्लाइंट निकाल लेगा, तो बोलेगा 100 रेन वाटर पाइप आए तो नहीं चलेगा. And this is for a particular friction factor, coefficient of roughness. If you use the smooth pipes, this increases. Let us say 150 mm, 100 pipe, 80 square meter is the area. If you use the smoother pipes. Stormwater design. This is the infrastructural stormwater design. This is not for building. So there is a rational formula. This formula is very popularly known in the civil engineering book as a rational formula. And this is, because now it is for the interpretation purpose, we have made it Q, but this is R is equal to CIA upon 360. R is runoff. That is same. Q and R is same. Can anybody tell me why it is striked out as a hectare and written square meter? Was it a mistake? Somebody didn't, somebody forgot to delete that? Can anybody tell? Okay. This formula is a very complex formula, although it looks very simple. C is coefficient of runoff, I is intensity of rainfall, and A is area. But if you do not select the rainfall intensity and area properly, then your results will be incorrect. If I take you to your 12th or first year engineering, anybody remembers dimensional analysis, LMT, length mass time, okay? Okay. You can go and Google and just become little nostalgic today to find out. But here I will tell you how it is relevant. This formula is a derived formula on actuals. And if rainfall intensity is in mm per hour, then the area has to be in square meter. So to highlight that you should not mistake, it is striked out. Why? Because somebody might say, I know two systems, MKS and CGS. So MKS में hour, दोनों में hour नहीं आता है. Hour is not there in MKS and CGS, but it is hour is there. But MKS में mm will be there, but hectare will not be there. So it is square meter. So this formula is little complex in terms of units, not from the multiplication purpose. If you can still take it in hectare, in that case, this 360 will get changed. You will find this formula is given differently in each book. Somebody is saying this is CIA upon 360, somebody is saying this is CIA upon 3600, somebody is mentioning CIA upon 3.6. That is based on rainfall intensity is universal in all the books, but surface area unit is different in all the books. So don't get confused, just use this. Then velocity, V is equal to 1 upon n, R raised to 2 by 3, S raised to half. Manning formula. Why Manning formula? Anybody? Why not Hazen-Williams formula? You all are engineers. So, Manning formula is for the open channel drainage, not under pressure. Whereas Hazen-Williams formula is for under pressure. I will give you one task. You can go home and do this, and one assignment also. Hazen-Williams formula is for pressure. Manning formula is for gravity. Then there is a Darcy-Weisbach formula. Then there is a Chase's formula. That sewage waste formula is equal to FLV square upon 2GD. Changes formula V is equal to C under root RS, and then there is a Coolbrook-White equation. You write down this word COOL BROK, sorry BROOK, Coolbrook-White WHIT. And next Saturday, if you come with an illustration, all these are explicit formulas. Coolbrook-White equation is the only equation which is implicit, where the friction factor is on both sides. Any one of you, or as much as of you, come with an illustration. एक simple example लेके आओ Coolbrook-White equation का, and you will get a good gift. Okay, I will gift you something very nice. That is also used for this water purpose only, but Coolbrook-White equation is mostly used in the sewage treatment plants which are used for cities. So sewage में क्या होता है? Sewage is consist of many things: solids, suspended solid, fibers, microorganisms. Many things are there. Not only suspended solids. So RWP again is rainwater pipe terminology. IMD, Indian Meteorological Department, area is there. TC, time of consultation. IDF is intensity, duration, frequency curve. So if any client is developing an area of 100 acre, the designer has to procure the data of rainfall intensity for that plot from the IMD. Indian Meteorological Department has established various rain gauge stations around the whole country, and you can buy the data from them for the rainfall. Now they don't give you mm per hour. They give you in some other vague format. You need to convert it mm per hour because your formula is mm per hour. So you get some data from them on which you develop the IDF curves. Then you get the mm per hour, and then you calculate the runoff for a particular plot. Okay, so it's a precise business. Siphonic roof drains.
Sir, that Q is equal to CIA divided by 360 for discharge, stormwater discharge unit is will be
meter cube per second, and that vary if you don't take it 360 again. So far what we see, we saw the gravity flows. Now there is a siphonic. So again one more childhood example. एक तो हमने देखा ट्यूब with thumb. Now in the college times दूसरे का पेट्रोल निकाल के हम लोग बाइक चला सकते हैं, ठीक है? So what we used to do, we used to take a tube, put it in the petrol tank of a friend, and suck with mouth, collect some petrol and use it. That is called as a siphonic action. Same here. But siphonic action will work when? If you submerge the tube inside the fluid. It will not work if the pipe is having only half filled. Okay. So same here. It is very efficient. It works very efficient. So siphonic roof drain, once the layer of water is filled, it works very efficiently. So even in small diameters, you can discharge huge rainwater. Even in small diameters, you can discharge huge rainwater with siphonic. So this table is for siphonic or non-siphonic. This is for non-siphonic. Gravity, हवा है, पानी चला जाए. Nowadays there are technologies are upcoming, areas are becoming very large. If you are designing a mall or community centers, town halls which has a very huge area, and somebody must have designed it with 150 downtakes. तो उन्होंने बोला, he is not wrong, but if we go with siphonic, the thumb rule is for 50 pipes you will only require one pipe. Thumb rule is, if you are taking the downtake of, let us say 75 mm, 50 downtakes, probably you will require one downtake of 150 mm. That is the thumb rule. But there is a very precise engineering behind siphonic roof drain, and it has to be calculated properly. Again, there is a primary and secondary, because if the rainfall is huge, then the secondary system will get in action. Unlike, as I said, it's a traditional. Every roof has a conventional roof drain system. It is not siphonic. Whereas large areas can have siphonic, it is a modern method of draining. This is the flow from conventional. So siphonic will work conventional also. If your rainfall is not up to the mark, it is not like a siphonic will not work at all. It will work like a conventional system. Because water is there, collection point is there, it will drain off. But it will not drain off efficiently. It will drain off conventionally. So if you want to drain off it efficiently, let the rainfall intensity should be more. Okay. So we don't need to have two systems, conventional also and siphonic also. We can have siphonic only, which will work conventionally also. In the less rainfall condition, this will be the pipe filled half probably. Once the rainfall is more, it is the siphonic action happens. Okay, it will be like this. The full flow will happen. Now, who will suck the air? It is natural, because it will start the flow like this. Eventually, it will grow. Eventually, it will go further, then more, and then it is a siphonic. I have seen the siphonic facilities. You will not even you cannot even see the water is flowing. Why? Because it looks like there is nothing. There is no air droplets. So siphonic action is also created within the system only. You don't need anything external to suck someone the pipe so that the flow can start. Okay. Advantages. See, every system comes with advantage and disadvantage. So far, the siphonic systems available are imported. So pipes are expensive, your inlet points are expensive. The installation is technically need to be done by a very skilled person, not like our regular plumber, plumbing contractor who can do a normal conventional, he can do the siphonic. Then there are tests need to be carried out properly. So various advantages and disadvantages. Of course, nobody writes disadvantage. Reduces the pipe size. As I said, that for 50, 75 pipe, you need one or two pipes of siphonic which will serve the purpose. The downtake pipe can be located conveniently as per architect. So, in this table, what we saw, every 56 meter square, you need 100 pipe. So, if I have 560 square meter area, I need 10 downtake pipe. Can they put conveniently? No. Every area need to have one pipe. I cannot put 5 pipes for one area, or 5 areas cannot start at one corner. Okay. So 10 areas need to have 10 pipes. If in the same time siphonic needs less pipe, so they can be conveniently placed. So architect is happy for that.
But sir, technically when we are talking about suppose 560 square meter area, like ridge and slope, so how that
So-
effectively 70, so 55 to 1 pipe conversion, that is practically not possible.
Exactly. That's why siphonic came into picture. That's why siphonic came into picture. For small areas, if it is, let us say, 1000 or 2000 square feet area, you can very well put conventional. But that conventional, the point here is how you will put conventional. Can you put conventional at one point? No, it has to be in the area. Whereas siphonic, you can concentrate in one line. All the roof area can slope to one point in one direction. You can put the siphonic here, all the points. Let us say you need 5 downtakes, you can put them near to each of them. So that is the beauty of the system.
Means you have to consider the slope factor.
Slope factor, yes, but it is available. In conventional, it is not available. You need to have reach valley, reach valley, reach valley.
And sir, primary and secondary, when you are talking about primary and secondary, so like at terrace we are having a primary system and secondary system. So that vertical downtakes are different.
Yes, complete system is duplicated for primary and secondary. Reduces cost, of course, less number of pipe, less cost. Aesthetically, it is better, more efficient in water flows in siphonic action, reduces underground drainage pipe, uses system full static head from gutter. So these are the advantages of siphonic. It will grow if the footprint grows. If the plots in the Mumbai get smaller, you will see lesser the siphonic system. Okay. Any questions?
One is manning formula, that is for open drain.
Open drain, which runs at gravity.
Gravity. And second one is southern unit, that is for
Pressure pipe.
And third what is it?
Darcy waste batch. That is again for pipe.
What?
Pipe. Darcy waste batch. DARCY, WEIS, BATCH.
And fourth one is
Chassis formula. CHEZZY. And assignment is for which one? Colebrook White. Any questions further?
in first section you said something related to like in 7 meter that is for standing
Suction head.
suction height.
Yes. For pump, any pump cannot have suction more than 7 meters.
Negative.
Negative suction cannot be more than 7 meters. That is a natural phenomenon.
Why 7 meter?
It has a bigger presentation than this. So, I have it, I will share it with you. Usually, I am happy that you asked this because usually, अच्छा 7 meter पता चला okay, I will not go beyond that. So,
Okay, so this is the our end of second day of training sessions. I think we will have our next on 5th of October. Again, you will get the mail from the office. What are the subjects and what are the training sessions? So we'll continue with the same timings again. Next session will be on the 5th of October. Thank you so very much, and thank you Amit also for giving fantastic presentations on both the subjects. Thank you so very much. I will let you know on Monday. I'll discuss with our chairman and I'll come back.